Welcome. This is our Algebra 2 quadratic functions, lesson number 8, shifting parabolas by completing the square, home review, part 1. If you have any questions or comments or want to leave, please do so in the comment section. And of course, if you find this video helpful, always give it a like, and look forward to seeing you in the next videos as well, because this is just the beginning. Number 1, which of the following equations will result from shifting y equals x squared 5 units right and 4 units up? And first off, when we see this, we're going to write our formula here for translation. So we're taking our xy, and in this case, 5 units to the right means we're adding 5 to the x value. And then 4 units up means we're adding 4 to the y value. But are we doing this for all our coordinates? Well, the most important one, especially since we see this, see that we have as a vertex form, is going to be the vertex. Okay, let's go over some rules in this case. To do so, we're going to shift the entire parabola. To translate a quadratic function, we want to rewrite the function in vertex form, which, if it's done already, is fantastic. Identify the vertex. Step 3 is translate the vertex, meaning you would take the vertex and translate with the rule they're given to us. And then step 4, write a parabola using the same a value from the original and with the new vertex. So we see here y equals x squared. Well, we know in this case our vertex form is y equals a times x minus h squared plus k. We see when we have here y equals x squared, the number in front of x squared is 1, so a equals 1. There's no number subtracting from x, so our h value is 0, and no number adding to k, so here our k value is 0 as well too. Really, our vertex is 0, 0, the origin, and we're familiar with the y equals x squared from so much use of it and all. That turning point we call it same as a vertex now. So that's our vertex. We are going to, at this point, translate the vertex with our rule. So we're going to take the x value, add 5, so 0 plus 5. Oops. Forgot to put the comma here. And then y value is 0, so we have 0 plus 4. So we're moving our vertex 5 units to the right, 4 units up, so our new vertex will be 5, 4. Now, what we're supposed to do at this point is going to plug into our vertex form, and our a value is still 1. Here our h value is 5, and our k value is 4. So when we plug into our formula, y equals a times x minus h squared plus k, we're plugging in 1 for a, 5 for h, and 4 for k. Now I recommend writing out this template and then filling the values, because sometimes we might mix up the values of the, especially inside of the x value. We see positive, we think it should be x plus 5. Instead, our equation is y equals x minus 5 squared plus 4. Okay, and I know some of you guys might have trouble with this, so write out the template for we have here for the vertex form, and then just plug in our h and k value, and of course a value too. So we see here we have y equals x minus 5 squared plus 4. It'll be choice 1. Question 2. Which of the following represents the turning point of the parabola whose equation is excuse me, y equals x plus 3 squared minus 7. Well, again, we'll go back to our vertex form. Y is equal to a times x minus h squared plus k. And underneath, I'll put down y equals x plus 3 squared minus 7. So we're going to kind of match things up in here, okay? So first off, I'm going to match up the k and the neg 7. So we see here k equals neg 7. All right? That's our first matchup. Our second matchup will be the inside. We have x minus h equals x plus 3. So you say, okay, well, how do I solve this? Well, you would solve like you normally do. We'd subtract x on both sides, because we want to find h. We see x's go away, and we're left with negative h equals 3. We divide both sides by negative 1 to get positive h, so our h value is negative 3. So our h value is negative 3, and our k value is negative 7. That would mean our vertex, which is h comma k, is negative 3 comma negative 7. And that's choice 4. Okay? When you do enough of these problems, you recognize in this case that inside the parenthesis, whatever number you see being attached with the x, it's the opposite for h. So you see here, if it's x plus 3, then the h value must be negative 3. You see x minus 4, then the h value must be plus 4. You'll notice this when we start doing translation of functions later. Which of the following quadratic functions would have a turning point at 6 comma negative 2? Again, we're relying on our vertex form of a parabola, y equals a times x minus h squared plus k. And here they tell us that our vertex, or turning point is another word for vertex, okay, just to let you guys know. And so our vertex is 6 comma negative 2. Therefore, our h value is 6, and our k value is negative 2. So now we just kind of plug into our formula. Y is equal to a times x minus blank squared plus k. Now here's the thing. They don't give us an a value, so we don't have to worry about which a value is correct, because we're really focused on the vertex or the turning point. So let's plug in the h value of 6 and the k value of negative 2. So we're looking for something that looks like y equals some number multiplying for a, x minus 6 squared minus 2. And this is the important point. Yes, the a values can differ, but really the turning point of the vertex is the key thing. Now, we've learned before about how the a value will make our parabola maybe thinner or wider, facing upwards or downwards. So the a value is not as important as the vertex. And the one that matches up here is going to be choice 3, because of the x minus 6 and of course the minus 2 here. Everything has to match up for the vertex h comma k. Number 4. Which of the following is the turning point of y equals x squared plus 12x minus 4? So for this one here, we have to find the vertex. We have two techniques that we know. One technique, of course, is to find the axis of symmetry, then plug in to find the vertex, the turning point. Plug in for the y value to find the matching y. We also have another technique, which is completing the square. Completing the square for a quadratic function, in this case for y equals x squared plus bx plus c. We'll move the c term over to the other side of the equation with the y value, and add blank spaces on both sides of the equation. Very similar to how we normally solve quadratic equations by completing the square. Divide the b term by 2, and then square that value. Put that number into the blank spaces. We're going to factor the quadratic expression, combine the values on the other side of the equation, but the difference now for solving quadratic equations is that we're not going to take the square of both sides. Instead, just get the constant term back on the other side and get y by itself. So we have here y equals x squared plus 12x minus 4. So we can add 4 to both sides. So we have y plus 4 is equal to, oops, forgot the blank. What do you mean by blank, sir? Blank means, in this case, that's the number we'll fill in, so on both sides of the equation. X squared plus 12x plus another blank. Okay, So we move the c term over, that was the -4. Now the b value is positive 12. So we see here b equals 12. So we want to take b over 2, and we get 12 over 2 is equal to 6. We then take the 6 value and square it to get a value of 36. And that's what we're adding to both sides, 36. We're now going to factor the right side of x squared plus 12x plus 36. And remember from before that it's just going to be x and x. And completing the square, we're plugging in positive 6 into both of these. That's how it works out, always when completing the square. Which means on the right side, we're going to get x plus 6 squared. Now on the left side, we're going to combine the 4 plus 36, so we have y plus 40. Now we're so close to finishing in this case. Last thing we'll do is subtract 40 on both sides. We have y equals x plus 6 squared minus 40. Now, what is this? This is the quadratic vertex form of the same quadratic function, except in the vertex form. And so we're comparing our vertex form here. I'll move down a little bit here. Our vertex form is y equals a times x minus h squared plus k. And we see here, we're going to just match up x minus h equals x plus 6, which means negative h equals positive 6, or divide both sides by -1. H equals negative 6. We match up k equal to negative 40. So our vertex or turning point will be hk, which is negative 6 comma negative 40. That's our vertex. Therefore, the answer for this one will be choice 2. Okay? All right, ladies and gentlemen, this is going to be the end of our Algebra 2 quadratic functions, lesson number 8, shifting parabolas by completing the square home review, part 1. I hope this was helpful, and they will get a little more challenging, but hopefully these notes that we had before about in this case being able to change the quadratic function into by completing the square to vertex form, and then use that to find our turning point will be very helpful for us. But again, we could also use axis symmetry and of course just plugging the x value into the y value to find turning point as well too. But hey, having more tools is always a good thing. All right, ladies and gentlemen, if you have found this video helpful, please give a like and subscribe to the channel. If you have not done so already, please do so, and then turn notifications to be alerted when new videos are added to the channel. Okay? All right, bye. I'll see you guys in the next video for part 2. Take care and be safe.